Okay. Uh, Perfect. Time for the webinar. Hello, everyone who's joining us from all across the globe. Welcome to another flight-based webinar. With us here for the first time, we have Eric Ebert, who is the founder and CEO of Falcon Unmanned Systems. He's one of our key partners in North America and is working on quite a few deployments with us. Hi, Eric. Go ahead, introduce yourself.
Hi everyone, I'm Eric. I'm founder and CEO of Falcon Unmanned Systems, like Nvidia said. I'm here to give you guys a look into the world of dock operations.
So Eric over here has done all kinds of dock deployments. He can put a dock on the ground, but also on moving vehicles and anywhere else that's needed. So pretty smart guy who's been in the field for a while, and we are going to see what he has been up to the last few months or so, what key learnings he's come with, and since dock and drone technology is moving so fast and everything is happening. It's sometimes tough to keep up with new practices, new workflows, and use cases that we can expand into. And this is an attempt at doing that. Um, so, as the webinar title speaks, we're going to actually talk about, the construction chaos when it comes to setting up, renewable energy fields. Eric, when people think about renewable energy construction, they picture rows of panels going up. What they don't actually see is the pressure behind the scenes, which is, I'm sure that you know the deadlines you might have faced, any alignment issue with like stakeholders across the map, placements, grading errors, and some more things that I'm probably not aware of. And I'm pretty sure you walked into this environment and, like we said, okay, we can bring daily autonomy into this, which is why we're here now. So let's. Why don't you take us back? What did renewable construction inspection actually look like before docked drones?
It was, it still is in certain parts, a actual pilot on the ground going out and flying and driving hours back because a lot of these sites are remote
Yeah.
to upload the data to be processed. The constructor is not seeing the data for hours or days at some points
Yeah.
to be able to act upon if there's a deviation from what the actual plan is and be able to correct it with enough time to where it's not going to cost the company enough of money.
Okay. And like, how big are these sites that we are talking about? I mean, what's the biggest one you worked with?
And the biggest one currently is about 2,100 acres as
Oh,
far
wow.
as dock operations, but we have sites that are 8, 9, 10,000 acres for solar.
Okay. Could you just explain to the audience what exactly piling is?
Piling is putting a large metal beam into the ground that actually
Mhm.
supports the solar panels.
Okay. And what happens if the piling is just like off by a few inches?
Off by a few inches puts the next row of panels off by a few inches, and so on and so on. It's a cascading effect.
And does that like come with any cost attached? Like, is there a big issue when it comes to it being off? Like, how does that work?
Once the piling is in the ground, it's hard to get the piling out of the ground. Is the problem?
Okay.
They're hammering them in essentially 10 to 12 feet into the ground,
Yeah.
and the elevation of it, as well as making sure it's perfectly straight up and down, makes a difference because if one is off, it throws the rest of them off.
Okay. And the rest of them being off compromises what exactly?
The whole project.
Okay.
To
But could
compromise
you?
the whole project, it could put every other panel off, every
Hmm.
module, every torque tube, every piece of the project could be affected
Yeah.
by one tube being bad.
Okay. I mean, so I can see how drones can be helpful over here, but like, how were teams checking before drones? Like, do you go one by one and just check each and every pile?
Yep. With the GPS receiver and the old school method and a plumb bob level.
Okay, and how long would that take?
Days, weeks
They
to check them
okay,
all. Yep.
so the biggest one you're working with, 2,100 acres. how much time would that take? As an just as an example.
Roughly about a month to check every pile. You're talking about
Oh,
20,000 piles.
okay. And how frequently does piling need to be checked when it comes to like construction? If it takes a month to check every pile, I mean, right now with your drones, I'm sure you're going over the same site at least once a day, right? And
Right.
you're getting like real time progress at every stage. If it just takes a month to go through the whole site once, what kind of data loss are we talking about?
By the time you end up checking all of them, another one could be off. This is why we saw a gap in the industry to transition to
Yeah.
daily daily reporting with analytics to where the
Mm-hmm.
contractor could act in real time.
Yeah. So, you had the problem and you saw like a place where you could add value and try something new. But how
Right.
did you actually like make daily autonomy real? What was like the first step in that whole initiative?
Lots of testing, testing different docking option, dock or drone in a box options, trying to figure out the best solution and
Hmm.
how when some of these solar sites are in the middle of nowhere, in the middle of a field, in the middle of essentially the country, how do we provide internet to it? This originally started
Hmm.
almost 3 years ago when there wasn't Starlink wasn't readily available yet. They had the first edition. Um,
Hmm.
there was a couple first edition of docks, and you start testing the actual hardware, and then you try and find a software to pair with it, and
Yeah.
test your pain points, test your fail safes, find
Mhm.
what works best for you in your scenario. Make sure you know the equipment inside and out. Test, test, test. There's never enough testing.
Yeah. And so before we get into the testing, did you try just like a remote control drone ops? Was that where you started off from, or were docked operations already in progress by the time you wanted to move into autonomy?
We started with a pilot on the ground flying it, and it became a lot of daily isn't an option. It can be weekly, but
Mm-hmm.
like we said, we saw the need for daily because if one thing goes wrong, it can affect the whole project down the line and kind of trickle down. And that's where
Yeah.
testing drone in a box solutions came into play.
Okay. So just to clarify, remote control pilots was happening kind of, but then you moved to dock drones, right?
Correct. I mean, we still use remote control pilots. We still use pilots on the ground for some sites that are
Mhm.
for the larger sites.
Oh, okay. And what's the difference? Like, what's the ROI on like having pilots on the ground versus like what's the difference between manual inspection, someone walking on those sites versus now having like a piloted drone? The image I'm trying to create over here is like manual inspection versus RC controlled drones versus docks, right? And
Okay.
clarifying, yeah, that's the image I'm
Yeah,
trying to fill.
manual inspection would take longer than piloted drone, boots on the ground. Essentially, it it takes that time frame and puts it in half. Having
Oh,
someone, they have to travel to the site, they have to fly the site, drive
mm-hmm.
back, upload the data versus a drone in a box solution is on site 24/7, can
Yeah.
fly at a moment's notice and upload the
Mm-hmm.
data as soon as it's landing, capturing
Got
it.
it. Yeah. And so when you installed your first dock on a renewable site, what did you expect?
Didn't know what to expect. We
Okay.
put it out there. We had a really good setup. The first dock went really really well. Surprisingly, we
Yeah.
deployed it on top of a container. And in all
Mm-hmm.
honesty, it wasn't supposed to go on top of a container. It was supposed to go on the ground.
Okay.
And when I showed up to site, the site was actually flooded because in the part of the country we were deploying at saw torrential raining, and they had 3 feet of water around all the office
Yeah.
trailers that they were working at, and there was fish swimming. around it.
Oh, okay.
So a nearby pond overflowed and flooded the site. And when I arrived, I said, we just can't put a dock there if it's going to flood again. It's a lot of money to
Yeah.
be submerged in water. So we pivoted on site as we were deploying and put it on a
Uh-huh.
container. And it have to think on your feet because your plan just went totally wrong. Like nothing of the plan happened the way it was supposed to happen.
They rarely seem to. But like I'm sure like putting it on top of a container was a feat within itself because you still had to like power the dock and all the wiring and everything needed to
It,
happen.
a little bit. The biggest feat was getting it actually on top of the dock. And when you're on these sites, safety is a priority. So finding someone to have a forklift to lift it or have a forklift to put it up on there, you have to be tethered off. Running
Yeah.
power to it isn't a problem. Putting a Starlink in an area that it's not going to throw interference to the dock is another one.
Yeah.
Um, but there's many factors, and we've
Mm-hmm.
how do I put it? Refined that process now a little bit more.
Yeah. And so, I mean, now you are running operations. I mean, we see them happening over flight base, and they're happening daily over numerous docks. Uh, what is what does that look like for you on the ground? Like, how many people do you actually have on site?
Currently, we have a team of four pilots flying
Yeah,
because of our one to many waiver.
yeah,
Um, it's an ops center essentially.
uh-huh,
We all work remotely. They have a similar
yeah,
setup with
yeah,
multiple monitors and a proprietary method of viewing multiple feeds at a time, along with
mm-hmm,
Flight Base's Fleet View. We've
yeah.
developed some methods that allow us to have oversight of everything that is in the air at the same time.
Got it. You mentioned the one-to-many waiver. Like, how many drones is it per
Yeah.
pilot?
Currently, we kind of set a limit at six, but our waiver allows us to go up to 12. So one pilot can operate up to 12 simultaneously.
Oh, that's pretty great. So going back to the missions themselves, so now you're doing them daily. What has to go right for the missions to feel like, a routine instead of stressful?
Weather is the biggest factor, and
Yeah.
even if a site is in close proximity to another site, we've learned
Mm-hmm.
that weather is the how do I put it? Weather is the most reported thing that is usually wrong.
Uh-huh.
You can have several different web applications opened or on your
Yeah.
phone, and each one will tell you a different thing.
Mm-hmm.
So we've learned to trust our systems with
Yeah.
our DJI docs and
Mm-hmm.
use multiple methods of verifying the weather on site. We're working on something else for the future to give
Yeah.
us real time weather on site, but weather is the biggest curveball.
Okay. And uh how many times, like maybe in a week or two, have you been thrown a curveball where you just can't fly because of the weather? Like, if you had to put a number to it, like,
Out of the 5 days, we usually have at least one day that we can't fly
hmm,
at one site, or we
yeah,
don't get 100% completion at that site because weather moved in and grounded us. It's usually right now this time in the United States. It's usually high winds or snow.
yeah, that's still significant number if it's happening like at least once a week, especially during the winter season, I would suppose. How long have you been doing these operations now with DJI Docs?
It will be coming up on just about a year here in June.
Okay,
So we've
so
seen we've seen both extremes now of
okay,
operating in very high heat temperatures and now operating in very low temperatures with
yeah.
snowfall, with rain, with sleet,
Hmm.
um, so forth and so on. And the docks have all held up really well.
Oh, that was going to be my next question, how the hardware was holding up. Could you like tell me what was the lowest temperature you've gone to?
I believe we've seen -10 Fahrenheit.
Okay, -10 Fahrenheit. That's around 5 or 10 degrees Celsius. Sorry, for people who don't do Fahrenheit, just converting. Okay, got it. And the highest, out of curiosity?
We've seen a dock temperature about 115 to 120 degrees
Oh,
Celsius, or not Celsius, Fahrenheit.
right. So that's around 50 degrees Celsius for yeah.
No,
Okay, that's pretty high for sure. I mean, I'm glad no one is, you don't have boots on the ground in these temperatures because uh, this is much better.
yeah.
Apart apart from your initial flooding and everything, when let's say your dock was now up and running, what is the first thing to break?
We haven't broken anything yet.
Really? So like, but
There,
like in
there has
terms,
not been there has not been a failure point as far as the DJI ecosystem goes that we've broken yet.
okay, but like, let's talk about, what your workflow currently looks like.
Okay. I mean, daily flights and uploads via Starlink. We have broken Starlink a couple times.
Okay.
Um,
Yeah.
Starlink just can't handle the amount of data we're pushing through it. Is
Okay.
probably the biggest problem right now. We have some solutions we're working on to get faster uploads out of those, but Starlink is definitely a limiting factor when you're doing daily ops of each dock essentially flying about 1,000 acres. We're
And
talking 2,000 acre site, and each we have two docks on the site, and we're flying about 1,000 acres apiece.
and how many images would that be per site per day?
About 20,000.
20,000 images. Wow. Okay. And so of course I can see how Starlink would be like a big pain point. But we know that the DJI dock itself only uploads one image at a time. How is that not been something you've been struggling? How you been trying to keep up with that?
Just being able to
Yeah.
prioritize uploads and push data through into a pipeline.
Yeah.
Um, with some help with Flightbase, we've developed an API to send it to our auto processing machine after it hits our servers.
Yeah.
Um, it just trying to accelerate every point that you can and get every ounce of data you can uploaded within our SLA timeframes in order to provide essentially
Mm-hmm.
a real-time analytic to the client the following day.
Okay. Got it. And so that's one dock, right? How long? Wait, how many docks are you currently operating? Just to
We
have
have
a rough.
12 operational.
Okay, 12 operational between, did you say four pilots?
Correct. Yep.
Okay. And how fast did you scale from like one dock to like 12 of them?
Exponentially. Once the first one was in and
Yeah.
the client saw the potential of it and how we could provide data, it's been nonstop ever since. It's been one after another. And a couple of days ago, I went and I deployed one in Oklahoma. I have another deployment coming up. It's been
Okay.
nonstop.
Okay.
I think
The way it's
in the next 90 days, I have 12 to deploy.
okay. Uh 12 to deploy. Wow. So this has been, when was the first dock that you deployed exactly?
It was the end of May last year, so we're coming up almost on a year. It was 9 months ago.
Yeah, so you have like 12 docs in 9 months, roughly, and then you have 12 more coming up, and I think even more after that, right?
Even
So,
more after that, there's another 30 slated to be deployed by essentially August.
wow. So basically, in 1.5 years, you're aiming for 50, 50, 60 docs ish. That's
Right.
a pretty fast scale.
It's
And
it's a very fast scale.
What worries you about this scale? Is there something that worries you?
Document management and maintenance management is the biggest thing that we're
Yeah,
seeing. Is we do daily documents of a flight risk assessment and some other things that are just to us, but keeping keeping track of everything. The biggest problem we've seen is keeping maintenance records. Um,
yeah,
when you fly every day and each dock is doing 10 to 15 flights a day, if not more, you
yeah,
you quickly realize you're going to hit the life cycle of batteries.
yeah.
That's and you don't realize it until it actually happens, because we have a site that's been deployed for a month and a half, 2 months, and it's caught up to a site that's been
Mm-hmm.
deployed for 4 or 5 months, just
Yeah,
because of the amount of acres it's flying. So then you have to schedule maintenance, go out there, replace batteries, replace propellers, um,
uh-huh,
and keep a way to track it. And I think we've solved that problem, at least for us
yeah,
internally, to track it. It's working right now, but keeping up with maintenance is probably the biggest thing. And a lot of these sites are
yeah,
dusty. Blow the dust out of the dock,
mm-hmm.
clean the camera up a little bit. Just try
Yeah.
and keep up with that.
I mean, I get it from like the hardware and the physical aspect, but you mentioned like 20,000 images per site per day. So if that's 60 docs, so that's I think like like that multiplies into a much bigger number. And if you're facing Starlink issues right now itself, like are you working with the client to come up with like some kind of infrastructure to support that?
As of right now, we're planning to stay with Starlink.
Yeah,
It's been reliable for us. We have higher speeds coming. We have a setup that we utilize a failover,
yeah.
as either another Starlink or a 5G modem to do some do some stuff in the background to get more speeds out of it.
Yeah, but would that, do you realistically, out of curiosity, would that be enough? Because if it's 20,000 per doc, that's by 60 docs,
Oh,
it's 1.6
20,000
million. Yeah,
twenty
it's around,
thousand per site. I mean, it's 10,000 per dock. So it's
okay,
roughly like 50 to 60 gigabytes a day per dock.
okay. Uh, Even if it like that's still 600K images every day though with those numbers, right? And uh
Yeah.
yeah, so that's a lot of infrastructure to build on, which is why I guess you're not just scaling all at once, but it's still a pretty fast process.
I like what we've developed with Flightbase. The auto processing pipeline has helped. It's taken a piece out of it to where, as long as the upload's complete and
Yeah,
there's no fallout, it automatically starts to process and then gives us a deliverable to deliver to the client. That's been a huge help. It gives us more time to let Starlink kind of do its thing with uploads. We're always trying to be as efficient as possible, and we
yeah,
obviously start as early as we can. So we start at sunrise and we fly until
uh-huh.
we're finished. Usually, excuse me, guys. Usually it's about 6 to 8 hours of flights, which then obviously gives you another 16 hours to upload and then process and then deliver to client. So try and get
Got
everything
it.
uploaded within about 8 hours, and then in another eight
Yeah,
hours processed and delivered to client.
yeah. And so what are you doing with these images, right? What is that post-processing that's happening? Could we talk about
It,
that a
it's
little?
it's essentially just being stitched into an ortho and then ran through a proprietary software for tagging.
Okay. Oh, we don't have to name the software, but I just want to know what exactly the software does.
It tags anomalies based on engineering drawings. So if a piling's off, if a torque tube is off, if a module's off, if a whole array is off a couple degrees, it tags it, um,
Okay.
utilizing some AI modeling to allow it to be corrected. It's all
Got
based off of engineering and CAD. It's as an as built.
Okay. And how long does it take to, like, once it has tagged an anomaly or an issue, how long does it take to actually, get that into action? Like, how long for someone to go and fix it, or what does that look like?
Usually, when an anomaly is detected or a deficiency is detected,
Yeah,
I mean, essentially, someone can go and verify that it's a deficiency as soon as they have the data in hand, and then it
yeah,
becomes a matter of what's the correction to fix the
mm,
problem, so it doesn't affect anything else on site.
yeah. Okay, that makes sense. Uh, so following about the continuous scaling that you're going to be doing, you told me you have four pilots right now. They have a waiver up to 12, but you are limiting that to six. So would you also be increasing the number of pilots on ground with this, or?
Yeah, that's the plan. We have a lineup of another 6 pilots that are already trained on flight pace's system and in our
Yeah.
operation style. It's a matter of when other docks come online, they come online, and we might be doing some rotating in and
Yeah.
get fresher eyes on a different site versus having
Mm-hmm.
someone consistently fly it. And there's benefits to both. There's benefits to having the same person fly a site every day. They pick up when things are off on site, if the weather's not showing what it's supposed to be, or
Yeah.
if just in this example, we had a dock that was reaching its battery cycle counts, and
Mm-hmm.
the pilot started to notice that it was charging slower. She wasn't getting as much done in one flight
Yeah.
as she was previously. We looked at the cycle counts and said, "Yep, it's time to change the battery. We have about 30 cycles left before we're at our max
Uh-huh.
life of the battery," and started scheduling it. And then immediately upon replacing batteries, she noticed the immediate difference, and it's helped tremendously. So having someone dedicated to a specific site for its life cycle
Mm-hmm.
benefits immensely, just picking up on things that are different.
That completely makes sense. And how I have not heard about, like, what about any, I'm just really curious about how you've managed to get the 1 to 12 waiver, right? Because not a lot of people that I know have it, and I think it's pretty tough to get it as well. What was that process for you?
I mean, honestly, I started off with not wasn't dock operations necessarily. I have multiple one to many waivers, at least 2 to 3,
Mm-hmm.
for just regular operations of boots on the ground. So um,
Yeah.
I essentially started off flying an 8,000 acre site with 2 Matrice 4s in the air at the same time, and quickly refined that workflow to where I can essentially fly about 1,000 acres an hour,
Yeah.
to cover the whole site in a day. So two
Right.
Matrice 4s going simultaneously with Smart Oblique, we cover about 1,000 acres a day. Battery charging isn't a problem. I have fast chargers, and DJI's ecosystem has been amazing. We
Yeah.
run Power 2000s and rapid chargers. I don't worry about charging batteries. That's something that
Yeah.
it can be misinterpreted when you go from a boots on the ground pilot to a drone in a box. Is
Mm.
when you're boots on the ground, you have unlimited batteries. You can swap batteries, you can charge batteries as fast as you can. When you get into the world of dock operations, you have no choice except to fly, charge, fly. That's what I train my pilots on: is fly, charge, fly, charge, fly, charge. It becomes almost a song, and that's if there was a native battery swapping method out there, it would be game changing. But at the same time, it takes 20-ish minutes to charge from 15 to 20% to 98% for DJI docks right now. So it's been very optimized, and that's at the point where we determined we needed multiple docks to cover a site just because of the fly charge fly cycles.
Yeah. Yeah. Completely make that completely makes sense. So, I think we're closing to our time, and we have a lot of questions to get through. So I just have a couple more, and then we'll be moving on to a lot of Q&A that people have. I'm just going to sum everything up for everyone first. We initially have these sites where you're building up these solar power constructions, and they're thousands, like they're like thousands of acres large, and the piling of solar panels has to be accurate, otherwise it throws the whole production into question, and it becomes problematic. It used to take a month roughly for a site as big as like 2100 acres for a map person on ground to inspect everything, and that got halved with remote controlled drones, and it got further halved with dock drones. So the current system that Eric and his clients are using is that they have these drones, they have a dock at each site, and it's flying every day, right? And it's collecting roughly 10,000 to 20,000 images. All of these images are then post processed. Eric, would you mind mentioning what software you're using for the processing itself, for the stitching of the images? uh how is that
we
happening, like?
we we use one of the available auto processors out there. Um,
Okay, do you
I
mind?
don't want to specifically mention any of the names, but it's one of the big three that are currently in the game.
And do you like manually download all those images and then like upload them over there? But isn't that like a lot of manual effort? How is that done? Uh,
It's all done via the webhook and the API. Everything goes from dock through Flightbase to our essentially S3 on Amazon, and then
yeah,
um, into the auto processing pipeline, and then it gets automatically sent to our platform to then start
yeah.
being tagged, and then into a one, two, three, four, fifth platform to then
Mhm.
be available to the client to see.
How long does this whole process take from
We
from
try
like
and
the start? Yeah,
from start to finish, like I said, we try and keep it within that 16-hour timeline. Obviously,
yeah,
there's things that throw that schedule off of if we don't finish a webhook, it kind of throws it off. We've adjusted timeout features and other things. I know you've worked very closely on this with us. It's been a journey for sure, but we've come to the point where I think we have everything figured out finally, and we're turning data around in that 16-hour,
yeah.
20-hour time frame as far as an SLA goes.
Yeah, I think like for you and I, it become because we have all this context and we've been working together for a while, it's easy for us to say,
Right.
yeah, we have a webhook over here and this is what the timeout does. But like, I think we
True.
need to we need to like explain it a little bit more for the audience. Like, what exactly do you mean when we're using a webhook, or what exactly is the timeout? Why was it needed?
So webhook, when the last image finishes uploading, it triggers an action to then push all the data into an auto processing queue, to where it starts
Hmm.
stitching the images together into a 2D ortho mosaic, which then,
Yeah,
once that is complete, triggers it to start tagging for analytics of if there's anything off compared
yeah,
to the as built. Um, a timeout feature is if it's stuck in uploading too long, it doesn't trigger the webhook. So if an image gets stuck in uploading for whatever reason, and some of
yeah,
it is DJI native, to where you might have 100 images that need to be uploaded, but only 98 were uploaded, it
yeah.
won't trigger the auto processing pipeline. So we essentially set a parameter to timeout, which allows us, when it hits that time frame of everything's not uploaded, it automatically starts the process of auto processing it.
Okay, and I'm curious, how does this issue happen often where, like maybe one or two images have not been uploaded? Like, how often do you see this?
It depends. Once a week, maybe it's when we see like a dropout in Starlink for the couple seconds that we see when it's transitioning from one satellite to the next. Um,
Yeah,
Other things could be a power cycle for whatever reason. We just last week we thought we had a power cord failure, and it wasn't a power cord failure. It was actually one of our battery backups that we run in our proprietary stands that failed. that put us offline for essentially 12 hours.
Yeah.
That was a rapid deployment to fix that problem, and there's many factors. Sometimes it's just it's like having a hiccup in the software, just in the webhook. Sometimes the webhook just doesn't push
Yeah.
it, or DGI system doesn't push one file, or it's categorized wrong for some reason. We're still working on a few little bugs, but for the most part, we haven't had any timeout issues.
And what are the repercussions of like this? Basically, any missed data, any false positives, or what? I guess it would be like the whole system, the whole process gets delayed, right?
Correct. Yes. Until we get a full data set, it's hard to deliver a full product to the client.
And like, are there times where you've just missed a couple of images? Has that happened? And
There has been in where the stitching software has came in the last few years. It adjusts accordingly for it to where you don't have a big hole in your data set. I mean,
yeah.
essentially you could miss two or three images in a row and still be able to stitch a ortho together that doesn't have holes in it, um,
Hmm.
or spots or so forth. There's multiple ways of changing that algorithm within the software.
Yeah. Got it. Perfect. I think like we've doubled down on a lot of points over here. We've gone through the problem, what the solution was. Just to quickly summarize the solution itself for the audience. Basically, as I said before, the drone flies, it captures all those images. We have a integration with the image stitching software that creates the orthomosaic. So all the images that are then automatically sent over there, right, via the webhooks. And then Eric mentioned the timeout feature because of certain failure points that are natively there in DJI, where a couple of images are sometimes not uploaded. So we had to come around and try to find a solution over there as well. And from there onwards, we have the client's proprietary software where all the failure point analysis is done for the construction itself. It's a it's a long process with a lot of pain points, and I think a lot of that we're still figuring out together as we go. And I'm sure there'll be a lot more unexpected curveballs coming up as we scale to 60 or more docs. Thank you, Eric, for listening to me talk and sharing all the points and feedbacks and answering all my questions. I think you just have to answer a few more by the audience, and then we'll let you go.
Yeah, no problem. I see one I would like to answer for sure. I see Josh asked the question,
Yeah.
at 115 degrees, what was your cool down recharge time? It was about an hour and a half, Josh. To be quite honest, and the biggest thing is trying to cool down the battery to a temperature that allows it to recharge. And I will share a little secret. Open the dock to expel all the hot air, and then close the dock to try and trap cooler air that the system's trying to cool. Is what we found. This We experienced this in a part of Texas to where it was very hot continuously. It was a good test for us, but keeping a dock heated or cooled is definitely a challenge, especially when you're trying to charge batteries quick enough to capture all the data for the day.
Perfect. We have a question by Naveen. He's asking, do you have a external weather station for monitoring, and how are you handling network?
There are some weather stations on site. We've found some of them to be inconsistent, so we're looking into a different manufacturer and potentially manufacturing our own. Network redundancy, as far as is a power, we always try to have a backup source. So if Starlink goes out, there's another Starlink out there, as well as a 5G backup if needed. But Starlink has been real reliable. Um, we've Only issues we've had is power sources, being able to power the dock long enough. And we have some partners that do off-grid trailers, to where essentially we don't have to rely on the site to provide power. Everything is all self-contained in a trailer.
Okay. The Stephen asking, no failures, no lost comms from Starlink. So I think we answered that already.
The,
Um,
right. The lost comm from Starlink is it's so fast that you barely notice it. It's a 1 to 2 second switchover. Essentially,
yeah,
you're missing the 1 point from when it transitions from one Starlink to another Starlink satellite. It's been very minimal.
got it. And have you ever tried LTE or 5G? We have seen 24 to 48-hour upload speeds with Starlink.
It's all about how you manage your Starlink. There's multiple different ways to manage it. We've learned that through our deployments. Um, it, it, Look at how you manage your Starlink. The Starlink router may not be the best option for you.
Uh, are you also doing thermal mapping missions along with RGB mapping missions with your current deployments?
Currently, we are not. We are just RGB.
Okay. Uh, just to like expand upon that, it's because they don't really need to do thermal mapping since RGB is what they require to actually, on the proprietary software to find where the faults lie. Building upon that, Eric, are you planning at some point, is thermal mapping going to be part of the process at any point?
We're trying to work it into our workflow before we go to demobilize the dock of potentially swapping from a Matrice 4D to a Matrice 4TD to do a thermal inspection once all the modules are live.
Yeah,
We're still working on that to make sure our processing can handle that, as well as bringing in one of my other partners to do the
yeah,
thermal analysis and tagging for it,
yeah.
so we can actually give a quality report to the actual site as it's finished.
Got it. And how would that like? I'm sure that would greatly change the current workflow that you have in set, right, between RGB versus thermal images. What do you hypothesize?
Flight routes would change as you fly perpendicular but parallel to the panels, so you're getting
Yeah.
inspections. You have a shorter time
Mm-hmm.
frame to fly because you have to capture the panels at a certain angle
Yeah.
at the highest sun point during the day, or we call it, at noon.
Uh-huh.
Um, and then just the processing of it. There's processing everything and then putting it through another tagging software, tagging deficiencies in the modules. It's
Yeah.
Thermal is a slower process. It's left more to the manned
Mm-hmm.
operations and not a DIB. But we've been doing some testing.
Is it actually even necessary? What exactly are you trying to find out by using thermal?
You're trying to make sure all the panels are live, or all the modules are live in the different strings, and make sure that there's not a
Hmm.
deficiency or a broken connection, that there's not already damage to some of the modules would be another
Okay.
one.
Okay. That makes sense. We're going to move on to the actual questions that
Yep.
people have asked. Josie is asking about the challenge of managing paperwork with so many docs. How have the available functions in Flightbase helped Mr. Ebert?
Do you want to answer that one in the video? I mean, we use the flight logs. We use flight logs within flight base, as well as flight reporting. There's a flight
Yeah,
report option. All my pilots do at the end of the week. We do them weekly, and tagging
yeah,
the issues. I mean, we also have the ticketing system within flight base, that any issues that happen throughout the day get reported immediately to the flight base, and we can track them.
yeah,
As well as I have a smart sheet that we also track stuff for
yeah.
redundancy in case something goes out. Um,
So
as far as
currently,
paperwork goes, just keep everything organized.
like, yeah, I think like currently, in terms of any the flight logs themselves, we are going to start an integration between your systems as well as like a fleet management system. So that's going to be pushing all the flight logs in the gutma format over there, and that's going to help you with fleet management. Apart from that, the reporting, as you mentioned, I think you would know that a little better. But we are, you as you said, the ticketing system, we are working on building that dashboard for you, right, where we are able to track like a customer facing dashboard where every ticket, every issue that's reported, you flag when it was reported, when it if when it is resolved, so you know the timeline to resolution, you know who exactly is like at what stage of resolution the ticket is at, you get and when you finally do have the resolution, what exactly the resolution was. That's
Right.
something I think your team and we are working towards creating in like a month and a half or so. So I think that would be interesting as well. Perfect. Let's go down. What will Zach is asking? Was that cool down time at 115 Fahrenheit with a Dock 2 or a Dock 3?
Zach, that was a Dock 2. Dock 3 cools a lot more efficiently, as well as keep heats more efficiently. There's if you're the big, I wouldn't say it's a cool down problem. It's more of cooling down the battery. Keeping the battery has a limit of essentially like 115 to 116. And once it reaches that point, it will not charge. So you have to bring the battery temperature down below 116, get it in the 110 range in order to charge. And when you're trying to charge a battery and cool a system, it just puts heat within the dock. So that's why when I mentioned open the dock doors to expel some of the heat and then close the dock doors and make sure the cooling is engaged, it helped tremendously.
Perfect. Derek is asking, when doing surveys with accuracy, do you use GCPS to increase your accuracy? If using GCPS, are the setup and permanent from the first survey? That is, what is your workflow for GCPs when
Uh,
using the dock?
we do have GCPs on site. They are currently not being integrated with dock operations. We are working on finalizing a workflow for that, as we've seen some inconsistencies versus a manned flight versus a dock flight. We're trying to narrow that down before we actually start processing with the GCPs in there.
Okay, I think like Derek had a follow-up question, which was how do you set up these GCPs? So I guess it's like if you in the future, how are you if you do it, how are you planning to set up these GCPs?
G, the biggest thing is you need to have an accurate way to tell the dock its location upon original setup.
Yeah.
The dock essentially creates its own RTK network after you've calibrated its location. So if you're just entering random coordinates off of the controller, it's not going to be as accurate as receiving corrections from an end trip or a core service. The most accurate way would be to set up a base station on site on a known point and cast those corrections upon initial deployment to the dock to get the best accuracy on the location of the dock. So then it could then pass the corrections. But the biggest misconception is if everything isn't on the same coordinate system, or everything doesn't have to be on the same coordinate system. Everything absolutely needs to be on the same coordinate reference system. So if you give the dock its location one way, you have to set up GCPs and measure them in the same manner. Um, when we initially deploy or when we do a maintenance visit would be the time that we set up GCPs, Derek.
Perfect. William is asking us, can you comment more on the computer vision anomaly detection on the platform that allows various models to be applied to the data? Also, are additional models applied beyond just comparison to engineering drawing?
Um, yes, there are additional models. I cannot comment on the platform. It is a proprietary method that we are not willing to share at this time. I apologize.
Okay, sure. But like without, we don't have to go into the details of the models themselves, but maybe you can talk about how exactly the anomaly detection or the computer vision is working, if possible.
It's like any AI tagging model. It tags deficiency based on a model that it's already been trained on. Um, it You can upload various AI models to it to be able to look at the pilings, look at the module alignment based off of the other module alignment. Um,
Hmm.
you're trying to see the alignment compared to the as-built drawings.
Oh, got it. I guess you just, yeah, it's really tough to talk about it without, actually talking about it. I get it.
Right.
But thank you for as much as you have told us. And like to sum it all up, what are the numbers looking like in terms of ROI? Because this is like an expensive operations within itself, right? Docs are not cheap. Having all these integrations, having all these processes, I mean, that's still like a very hefty number. So, what's the ROI looking like?
We're seeing margins in the 30 to 40% as far as ROI goes. I mean, the with depreciation and wear and tear on the docks, I mean, we have a partner who also runs dock operations, and we haven't seen a failure point. And
Yeah,
there's not much that can break or even has broken on a dock. Like I said, we haven't seen a failure point. It's been always something that you didn't think would fail versus trying to plan for the dock failing. And
yeah,
that just comes down to having availability of parts and the distributor you're working with. We have a really good partner here in the U.S. who has kept the supply chain flowing to us.
yeah,
They're a great partner. They're not too far from me. They're up in Minnesota. It helps. It helps when you have a local distributor who also supports your scaling needs, and that doesn't create a bottleneck. Um,
got it.
know your
But like,
docs and be go ahead.
sorry to interrupt, but like apart from money that you're spending or getting receiving from this, right? What else counts as ROI for you?
Being able to deliver exactly what I said. It keeps credibility there, and all of my clients and my clients' clients are seeing the real time analytics and the data that we're providing to these sites to where they can act a week, a month, uh, anything sooner than what they were seeing before to correct a deficiency. Because if they don't have what we're providing currently, they can put themselves behind, which just costs the site even more money.
Yeah. So we've gone basically from like a month, like things taking a month to things taking a day, less than a day, right? More or less. So
24 hour turnaround. So real time analytics on delivering data so they can make a correction if there is a correction that needs to be made.
yeah, perfect. So like you save on the time to travel, you save on the person actually having to walk the field, you save on like all that manpower and manual efforts. And I guess anything else that I'm missing out that we're saving on over here?
Um, no, I mean those are the biggest ones that we look at.
Okay, perfect. Thank you. Oh, one more question. Sorry, Eric. Other than batteries, cycle limits, what maintenance are you having to do for the dock and drone? Is this different in different areas?
We've seen a lot of dust ingestion by the dock. So we're
Yeah,
doing a lot of just like any computer. I mean, if you think of a desktop computer, it has fans that are trying to keep it cool, so it's going to bring in dust. Natively, these sites are very dusty, especially during the early stages when they're doing civil work. So trying to blow all the dust out of them. Um, Battery cycling is another one. We've with as much as we're flying, like I said, we've replaced batteries, propellers. When you do a battery, I mean, you're at 400 cycles, you might as well replace propellers. The propellers have an anti-icing coating on them that we've been talking with DJI about, as far as if there's any effect and if there's a risk of delamination with the propellers. If that coating is coming off, we haven't seen any adverse effects or any decrease in efficiency from those propellers. That's really it. Do a wipe down and keep them clean and blow the dust out of them. They're pretty self sufficient to where as long as you maintain them or change the oil on them like you would change the oil on your car, they're good to go.
got it. All right, perfect. I think we have gone through all the questions, and I think I have asked you plenty of questions myself. So, Eric, thank you so much for joining us. I think you gave a lot of clarity to a lot of people about actual dock operations, hardware maintenance, and finally how to deal with like really huge data sets. Uh, thank you so much. If you have any last comments to make, uh, after that, we'll be closing the webinar.
I think I'm good. I mean, my biggest thing is come up with a plan and execute it and be ready for a curveball and be ready to scale beyond belief because if I look back at this time last year, I would tell you, nope, not gonna not gonna be scaling the way I am. But I had great support from some friends and from some team members that really pushed through and scale. I'm scaling beyond belief, which is the crazy part about it.
I like if you, I mean, if you had to tell somebody who was in your shoes, who was going to face the same problems you have been, what's like the piece of advice you would give that person?
Don't listen to everybody. Put all your eggs in one basket when you're trying to scale. Find your niche market and push hard.
Got it. All right, perfect. On that note, I think we are good to close. Thank you, Eric, and thank you everyone for joining us. As usual, great questions, great conversations, and we'll see you again next time. Bye.
Thanks, everyone.